here I have this hot plate with 3 cans on it, and I have placed a small quantity of water inside each of them. You might be able to see the steam rising from them. That is an indication of the fact that all 3 of these cans are filled to the brim with hot steam. And then I will grab one of them and dunk them in this vat of ice water, and it should crush rather quickly. If I can grab one. Like that. This project is actually safe enough to do at home if you can get a setup like mine. Now that you've seen me do it, you can stop the video and go to your lab sheet and answer the questions regarding Station 1 and come back. Here at Station 2 I have this helium-filled balloon and an assortment of hot objects. This balloon is attached to a string, and the idea is when I take these hot objects and I place them under the balloon, it should take the heat and lift on its own eventually. As you can see, you're starting to get some rise now, and there it goes. Since the air up there is cooler, it should come down eventually, and then once it reaches this point where it's hot again, it'll just go back up and just bob up and down.
Or it may reach equilibrium, just take it.
Now the balloon, as it gets hotter, it rises and it falls when it gets cooler. So you'll probably talk about that on your lab worksheet. So you stop the video now and answer those and come back. Here at Station 3 we have a bottle with a thermometer inside, if you can believe that that's a thermometer. And I'll just hook it up to this bicycle pump and increase the pressure. We should see an increase in the temperature as well as I put more air into it. 64. Turn blue. Don't forget to stop the video and answer the questions on your lab sheet. Here at Station 4 I have a 2-liter bottle filled with water almost to the top, but with a small pocket of air up here, as you can see, and some ketchup packets and a dropper pipette with a nut to give it some weight. And what I'm going to do is I'm going to fill this with more air, increasing the pressure using this fizz keeper, which is normally used to keep your soda carbonated after you've opened the bottle already. And we'll watch what happens. Come on. There it goes. I don't know if you can see this, but they have in fact sank to the bottom, and when I release the pressure, float back up to the top. Again, don't forget to stop the video now and answer the questions on your lab sheet. Here at Station 5, I have these poor marshmallows that I'm going to test for science, and what I'm going to do is I'm going to take one of them and I'm going to place it inside of this syringe. I'll push the top end slightly and then screw on the bottom and compress it greatly. Then when I release it, it will return to its original size.
Okay.
Now I'll put him back and pick another one, and this time instead of putting a lot of volume and low pressure and increasing it, I'll start low and go to, or start high and go to low. Sorry. As you can see now, he's normal size. I'll compress him a little. Then he will expand as I release the pressure. And then compress as I increase it. Stop the video! Do your lab worksheet! Here I have this pile of straws that I'm going to increase the pressure inside, and then somebody will decrease it very quickly and there will be a nice popping sound. Just take one of these and need you to flick. Nice. That was great. Okay, so now that we've done that, make sure that you stop and fill out your worksheets again. Here we have a thermometer and some nail polish remover, which has the active ingredient of acetone, and that's what we're going to be looking at. Gonna dip this thermometer into the acetone and then remove it and watch what happens to the temperature as it evaporates off of the thermometer, and we'll record the temperatures that we see. Here at Station 8 we have the same bottle, and we're going to take this syringe, which currently has 4 milliliters of trapped air inside of it. I'm going to place it inside the bottle, and then I'm going to attach it to this bicycle pump, and we're going to watch what happens to the volume of the syringe as we increase the pressure inside the bottle. As you can see, it's decreasing. Currently, you'll need to know the volume of the syringe right now, which is about 1.5 milliliters, and the pressure from the bicycle pump is 35 pounds per square inch. You can convert that to your necessary units. And of course, as always, make sure to stop the video and answer the questions on your worksheet. Here are at station number 9 with the mystery flask. So, as you can see, I have this balloon which has been sucked inside of this flask somehow, and your job is to tell me how did this balloon get sucked inside of the flask, and how can I get it out without touching it? First act, we have scissors. Now somebody's gonna die with them in the final.
Fewer words.
Okay.
To the point.
No, leave. Don't forget to stop the video and answer your lab sheet questions. At Station 5, I have an assortment of marshmallow subjects that I... Station 5 here I have this family of marshmallow emojis that Here at Station 5, I will torture these poor marshmallows for some. Can't say it.
You can do it.
You think I told them to stop the video enough?